NASA, don't press the red button just yet. Oh hi, sorry, didn't see you there. I'm Professor Spooner, and I'm here today to talk to you about good coral viruses. Now, when we think of viruses in 2020, our minds immediately associate the word virus with...
No, this is not the time simply to end the lockdown this week.
Although it might be true that some viruses are associated with, well, shall I say, many depressive issues, what if I told you that some viral strains may be the key to ensuring reef survival in the future, helping them boost their resilience to climate change, to the warming and acidifying conditions?
To understand their role in coral reefs, we must first understand what viruses are and why they are found in corals. Viruses can be simply described as submicroscopic infectious agents that need a host living cell in which they can replicate themselves. A coral is a complex organism made up of the coral unit, symbiotic algae known as zooxanthellae, as well as its associated microbiome known as the holobiont. The holobiont is made up of endolithic algae, bacteria, archaea, fungi, and of course viruses, which all contribute in some way to how a coral functions. A meta-analysis of coral sequencing studies have revealed approximately 60 virus families are associated with corals.
Virology is a growing field in coral reef research, mainly because studies have correlated viral diseases to increased frequency of bleaching events. However, recent studies are now only beginning to understand how some viral strains may actually benefit corals and their symbiotic partners, where mutualistic relationships are emerging.
Viruses are very important to the survival of corals. Corals continuously protect themselves with a mucus layer on their surface which acts as a protective buffer against their external environment. Mucus provides protection against fouling, desiccation during air exposure, and prevents sedimentation. This mucus layer is estimated to contain 30 million viruses per milliliter. Bacteriophages are abundant in the microbiome of even healthy corals. They're likely to be involved in complex ecological networks, genetic material transfer, and selective co-evolution within the surface mucus layers and tissues. Early studies are already suggesting that viruses in the microbiome may play an important role in corals' metabolic interactions, immunity to disease, and increasing stress tolerance. It has been assumed that the manipulation of a coral's microbiome will be able to genetically enhance the resilience of corals to a warming and acidifying ocean.
One of the main issues associated with how viruses are beneficial to corals is lack of understanding. Although our ability to describe these viral communities has developed rapidly with the advent of next-generation sequencing, their ecological role in health and disease is still poorly understood. Lab culturing techniques are still in development, and we have only recently started to explore the idea of how manipulating the holobiont can actually help corals in an effort to try and survive climate change.
As our understanding of how the microbiome of corals can be manipulated to help boost resilience against the consequences of climate change unfolds, these manipulation techniques should be implemented into reef restoration and conservation strategies worldwide to ensure coral reefs can continue to thrive in the future.
Thank you for watching. I'd like to acknowledge Essex University for their help. Don't forget to like and subscribe, and stay safe.